Hi there, on this screencast I'm going to go over what z-scores are, what they mean, and how to use a z-score table. So the first thing that you'll want to know is what does a standard distribution look like, and what do these percentages and what do these values underneath along the x-axis mean? Well, if something's distributed normally, and the middle right here is considered the mean value, then you will automatically know that within negative zero point 0.5 standard deviations away from the mean, 19.1% of the data is going to exist between negative zero point 0.5 and 0. Uh, if we go down to negative 2 standard deviations away from the mean, we would know that you would add up these percentages to get the total amount of data that is going to be in between in that range. So what is the z-score? Well, the z-score for any piece of data any data set that's distributed normally, the z-score tells you how many standard deviations away from the mean that piece of data would be. And by letting you know how far away it is from the mean, you can then use that information to compute the percentages that are lower than that value and the percentages that are higher than that value, and or even the percentages that are within a specific range. So the formula for finding the standard or the z-score for a value is the actual piece of data minus the mean value of the data divided by the standard deviation. So typically you're gonna need three pieces of information to find a z-score. The data value that you're looking up, and that could be anywhere. That data value could be anywhere in the spectrum of, anywhere from the lowest of the low to the highest of the high possible values of data that you want to know the z-score for. The mean, which is the average value or of the mean of the data, and the standard deviation of the data. So those three values should be given to you in questions that involve z-scores, and you simply need to plug in the values and do the math. Now, if you get a z-score for a value, what does that tell you? Well, if we go back to, let me see, if we go back to this graph, if we know a specific z-score, we can know exactly what percentage are less than that value and what percentage of the data are more than that value. All right, and how do we know exactly? Well, in this graph, it's just divided into sections that are 0.5 do standard deviations apart. Well, if there tables exist, and one set is in the notes, and this is the yellow sheet that I handed out in class, that allow you to look up a z-score up to 2 decimal places and then look at what value that is. So if we go to the z-score table, so let me go over to my document that has the tables in it. Okay, so typically you're going to have a z-score value for the positive values and a z-score table for the negative values. So what is the z-score actually? What are these numbers in here that you look up for a specific z-score, and how do you look up a specific z-score and determine which of the cells, what number is relevant? Okay, so first of all, how do you look up one of these values in here? Well, given a z-score. Well, you go, and the row that you're going to look in are the first few digits of your z-score. So if I had negative 2.49, if I was looking that up, I would go to negative 2.4, and then I would add another 0.09 for my column, and that's going to give me 0.0064. So what does 0.0064 mean? it means that 6.4% of the data, or no, I'm sorry, 0.64% of the data is actually less than negative 2.4 standard deviations below the mean. Let's say that I came up with a z-value of negative 0.711. Well, I'd go to negative zero point 0.7 for my row right here, and I'd go to 0.01 for the column, and that value 0.2389 means that 23.89% of the data is going to be found to the left of that z-score, and then the other percent is going to be found to the right of the z-score. And if you know the amount that's less than the z-score, which is what all these values are in here, then obviously percents have to add up to 100. Then you would automatically know what percent, you could figure out what percent is higher by simply subtracting the lower value from 100, because you know these two sides have to add up to 100. So in the problems, in the homework, in the first one, which is problem number 6, it says a recent internet survey showed lodging expenses at Disney World range from 100 for a campsite to more than 2,000 for top luxury room. The cost per day of the 10 most popular hotels at Disney World was 348. If the standard deviation was 80, find the z-score for a per day expense of $400. Okay, well, your data value that you're looking for in the formula is going to be 400. The mean value is 348, and the standard deviation is 80. So those are the 3 pieces of information you would need to use that formula to compute the z-score. So then it says if data are approximately normally distributed with mean 348 and standard deviation of 80, what percent of the hotels have per day expenses of greater than 268? All right, so to do this problem, you would need to find the percent that have per day expenses less than 268. And then, since the question is how many would have more than $268, you would just subtract the percent that's less than, which is what you find in the z table, from 100. So if I were doing it, the 3 pieces of data that I need are the mean, the actual value, which is 268, and 80. So I would do the math, and I think it's 268 minus 348 all divided by 80. So 268 minus 348 is 268 minus 348 is negative 80. Okay, so then I divide by the standard deviation and I get negative 1.0. So that's the z-score for $268. So that means if I go back to my tables, my z-score value, and I look up negative 1.0, so I want the negative one. So that's the positive one. Let me go to the negative one. And I'm going to look up negative 1 is right over here, 0.0. So that's 0.1397, which is 13.79% are less than that value. So that would mean 13.79% are less than $268. Well, you're either less than it or greater than it. So if you know how much is less than, you can figure out how much is greater than by subtracting that out from 100. So I would do 100 minus 13 point, whatever that value was, percent, and that would give you your answer. Okay, so I've talked you through the homework problem, and hope that helps. And make sure you show your work when you're doing your homework. I should have mentioned that in class, but you know, I'll mention that again. And by the way, the homework is on page 10 of the notes. I may make a separate file for it so that you don't have to open all the notes and go to page 10. But if you just have the notes, it's attached to the end on page 10. All right, Hope that helps, and we will see you next week. And some of you, no, I guess I'll see all of you next Tuesday, Monday, next Monday. All right, cheers.